we are going to review finding the domain and range of some functions. If you have the book, you can turn on to page 65. Let's take a look at the exercise number 1. Find the domain and range of the function f of x equals 5x minus 10. Well, this is a linear function. The linear function, you can see the slope is equal to 5, and y-intercept is located at 0, negative 10. So for all the linear function, it has its domain as all the real numbers from negative infinity to positive infinity. And the range is also all the real numbers. Let's take a look at another problem, which is not a linear function. If you take a look at number 3, you can see they have a square root. Every time when you see a square root, make sure the expression inside square root with the radicand should be non-negative. In here, you can see the radicand is only in row x, so I need to make sure x must be non-negative, which is greater than or equal to 0. And you want to write that as an interval. Think about the number line on x-axis. If 0 is right here, greater than or equal to 0 will be on the right-hand side of the number line. Equals indicated including this endpoint, so it will be a bracket all the way to infinity. So the interval is from 0 to infinity. That is our domain. Now what's the range? When you take a look at this square root of x, okay, when you take a look of square root of x, taking square root of x, that must be greater than or equal to 0, right? And if you take the negative of that, that will be less than or equal to 0. Switch the inequality sign and add the 15 from both sides. That will be less than or equal to 15. Then indicate our range will be from negative infinity to 15, including the 15. Also, you can get that information from graph. I'm going to use in graph. Think about the way we learn about the transformation. If we study from a function of square root of x, that's our parent function. Square root of x, it will be somehow looks like this. Y equals square root of x. You should use the transformation. Think about the negative square root of x. That will be the reflection about x-axis. So the graph will be going like an image of about the lake. So this is the graph of y equals negative square root of x. Plus 15 is y equals 15 minus square root of x is the same idea as negative square root of x plus 15. You have output plus 15. That's a vertically shift up 15 unit, which the point from 0, 0 will shoot up to, that's assuming the 15 is right here. It shoot up to here. So your graph, it looks like this. Okay. And take a look at this graph. You can see the graph is starting from 15 and going to infinity, negative infinity down here. So this part is your range, which is we can get like the one we did algebraically. Right, so those are the domain and range. Let's review the linear to graph the piecewise function. Piecewise function, of course, they are pieces, right? Let's take a look at this function. It has 2 pieces, and one piece is on the left-hand side of 2, not including 2. One piece is greater than or equal to 2, which is on the right-hand side of 2. In class, we were talking about we can use some points to graph these functions, left-hand side and right-hand side. and I take a look at these two functions, then they both are linear function. Let's give me some x and y. Okay, x, y, and I'm going to grab the left piece. So I need to find some points from the left side of 2, which is not, maybe 0, 1, they're less than 2, right? And also I wanted to see what it approaching to at 2, but I keep that in my mind. This is not including this point. I use open circle for that one. If x equal to 0, use the first piece to evaluate that. 2 minus 2 times 0, that will be 2. The second point is 2 minus 2 times 1, that's 0. And this is 2 minus 2 times 2, that will be negative 2. Alright, let's see what we can get from the graph. X-axis and y-axis. Here's the origin. And x equal to 2, that is our breaking point. 1, 2. So I know that on the left hand side with one piece, right hand side with 2 will be another piece. The left hand side piece I used 3 points. 1, 0 is corresponding to 2. If you take a look at the slope of that linear line is a negative, so we see that it's decreasing function. Okay, so it will be 0, 2. Second point will be 1, 0. Oh, that is our x-intercept. And the next point will be 2, negative 2. Right here. And I know that this point, be careful, we are not included, so we will use open circle to connect that. And this is my left hand side piece, and it's going to infinity. Right? So that's my left hand side piece. Let's take a look at the right hand side piece. Right hand side piece is starting from 2 and everything greater than or equal to 2. I can use 3 or 4, and this one is the boundary, but I will include in this point. So that one we will be using the second piece to evaluate. 2 minus 2, that's 0. 3 minus 2, that is 1. 4 minus 2 equals 2. So that will be 2, 0 right here. X-intercept right here, and 3, 1 will be this point. 4 is corresponding to 2 will be this point, and including this point, right? So let's connect that, and that's the second piece. So that's piecewise function. We have 2 pieces defined and 2 pieces graphed in here. Let's take a look at another one piecewise functions. Well, these are 3 pieces, 1, 2, 3, and the interval will be cut between 0, 20, 20, 100, greater than 100. It seems like x doesn't have any negative number because there's nothing on the left hand side of 0. Let's see. Similarly, I can use some points to help me with the graph. Of course, to some of the students are advanced, you can just use the slope intercept form because they are all linear lines, right? You can take advantage of that. Okay, so this is x and that's y, and I can see one piece is between 0 and 20. 0, oh, they both including the endpoint. Maybe I just can use these 2 points to grab a line. 2 points determine a line, right? When x equal to 0, that is 4 times 0 plus 20, that will be 20. When x equal to 20, 4 times 20 plus 20, that is 100. That's the first piece. Let me finish up those. The second piece, 20 is not including, but if we approach into here, okay, open circle, 2 times 20 plus 60, that is, well, they overlap with this point, so it's 100. And how about when x equal to 100, that's including the endpoint, that will be 2 times 100 plus 60, that's 260 right here. And the next one is greater than 100, starting from 100 but not including 100, that will be negative 100 plus 360 equals 260. Is that coincident? They are the same point. And how about I'm going to use x equal to 200. Okay. And that will be negative 200 plus 360 equals 160. Okay. So that is the third piece. 1, 2, 3 for these pieces. I'm going to grab these functions. Hopefully I can make arrangement of the x and y coordinate in a smart way. So let's see. Since I don't have any negative x, I'm going to have my y-axis a bit closer to the left-hand side. And I have x's, let me see, maybe I can use as each unit as 10. That's 100. 200. And y-intercept I will have 300 over there. So 100. Not showing up there. Okay, so the first point is 0, 20. So we'll be right here, starting from here, and then 20 corresponding to 100, which is right here. And I stop at this point. So the first piece is this blue piece. It's a 7. The second piece is x equal to 20, y is 100, x equal to 100, y is 260. Oops, all the way up here. So that is the point including is 100, 260. Include this. So that is my second piece. The third piece, I'm going to use purple line, x equal to 100, still this point, and x equal to 200, that will drop down to 160. Right here. And this is greater than, right? So we'll be going to infinity on this side. So that is piecewise functions, and I will see you next time.